AB readily decomposes at 1400 kelvins, but not at 800 kelvins, because at 800 kelvins, delta H is what? Delta H is your enthalpy, which is like change in heat. But look at this question. It says AB readily decomposes at this temperature. That means at 1400 kelvins, the decomposition is spontaneous, right? Something that's spontaneous has a negative Gibbs free energy, and something that's non-spontaneous is going to have a positive Gibbs free energy. So at 800 kelvins, it's not readily decomposing, which means at 800 kelvins, it's non-spontaneous. So at 800 kelvins, it has a positive delta G. A formula that can help us find delta G is delta H minus T delta S, right? And so look at this equation real quick. We started with one molecule, and it breaks down into two, right? We went from one thing to two things. And there's more molecules of gas than there was to begin with, right? Over here, there's 0. Over here, there's 1. So now that there's more gases and more molecules, the entropy increases, right? Because entropy has to do with like disorderedness, right? And so our delta S is going to be positive, right? What I'm trying to do is I'm figuring out what T delta S is, okay? So our temperature is 800 Kelvin. So what we have is delta H minus, but like 800 Kelvin. And just for simplicity, I'm going to call delta S positive 1, right? But the main idea is that T delta S, right? T delta S is going to be positive value, okay? So if we want our delta G to be a positive value, then what is delta H going to be here? Delta H has to be greater than 800, right? If we have something like, 600 minus 800, this is going to give us a negative delta G, okay? So in order to get a positive delta G, we need something greater. So we can say like even 801, right? If delta H is 801, your resulting value is going to be 1, which is positive, okay? So that's going to give us choice B, because our delta H has to be positive, right? It can't be negative, otherwise it won't make the delta G positive, right? Positive, and it also has to be greater than T delta S, as we just established.